Hello and welcome to Aryabhata Ashram. I am M. Maheep. We are doing daily answer writing practice of PYQ of Mathematics Optional. This will be a harbinger of change for your UPSC preparation. One question a day will keep you ticking. So this is a question from complex analysis. It says using contour integration, evaluate 0 to 2 pi d theta upon 3 plus 2 sine theta. This is asked for 20 marks. Well, this sounds simple question. This is a question unit circle. But first thing first, can I get an answer quickly? A quick answer to this question is simply, this is if I have a unit circle integration, whether I have a sine or cos or whatever. So answer is simply 2 pi upon under root of a square minus b square. So here I can see the answer is 2 pi upon root 9 minus 4. So answer is 2 pi upon root 5. Now I know the answer. It is of 20 marks. How do I resolve this process? How do I do the due process? So the process is very simple. Again, I have certain things in my mind. Like-minded question, 0 to 2 pi d theta. UPSC asked this question in IFoS 2006. 0 to 2 pi d theta alpha plus beta sine theta plus gamma cos theta is equal to 2 pi upon alpha square minus beta square minus gamma square if alpha square is greater than beta square plus gamma square. So this was the question asked by UPSC in Civil Services Examination 2006. Not only that, they have also asked certain questions like this: 0 to pi d theta 1 plus half cos theta. So I have quick answers to these questions, and this is a question asked in Civil Services Examination 2014. Now for this we have a quick formula: 0 to 2 pi d theta a plus b cos theta ka whole square is equal to 2 pi a upon a square minus b square to the power half. Now this is 0 to pi, so you need to convert it into 0 to 2 pi to make it on a unit circle. You have to keep that in mind. So all these things have a pattern, symmetry and harmony. If you see mathematics from different point of view, you will be able to understand its gist. You will be able to understand that methodologies are different, but they lead you to the same path. Again, if I do the integration in indefinite integral or a definite integral, what I do, I convert sine theta or cos theta into tan half theta by 2, so on and so forth. Okay, but here that is not the issue. Here the issue is that we need to do by contour integration, so you have to follow that procedure. So I have a question: 0 to 2 pi d theta 3 plus 2 sine theta, right? Now this is on a unit circle. So on a unit circle, I can very well say that z is equal to e to the power I theta, correct? And sine theta is nothing but e to the power I theta minus e to the power minus I theta upon 2i. Now this can be written as 1 upon 2z, z minus 1 by z. This is equal to z square minus 1, 2iz. Now I also want the value of dz. dz is I ei theta d theta. So d theta is nothing but dz upon iz. I also want the value of 3 plus 2 cos, 3 plus 2 sine theta. So 3 plus 2 sine theta is equal to 3 plus z square minus 1 upon 2iz into 2. So 2 get cancelled. So I have 6iz, no, it's 3iz plus z square minus 1. So this is the value. So if I substitute 0 to 2 pi d theta 3 plus 2 sine theta d theta, now this d theta is dz upon 1 by z, and this is z square plus 3iz minus 1 upon iz, correct, because I also have an iz here. So this iz get cancelled. So I can convert this to a contour integration, and this is over a unit half circle. So if my alpha betas are the roots, so I can very well say that z square plus 3iz minus alpha. So alpha beta are nothing but minus 3i plus minus root of 9i square plus 4 upon 2. So this is nothing but minus 3i plus minus root of minus 5 upon 2. So this is minus 3i plus minus root of 5i upon 2. So alpha and beta values are found out. So alpha value is minus 3 plus root 5 upon 2i. Now this is lying on completely on imaginary axis, alpha beta. Point is that what is inside a unit circle and what is inside a unit circle. If you can make out, then the whole solution is found out. Now you can see here, this is a unit circle, mod z is equal to 1 and minus 3 plus root 5. So this is inside this unit circle. So I can say that my alpha is here, whereas my beta is outside this unit circle and it is on imaginary axis. That is for sure. So once you understand this concept, now what is the residue that I need to find out? So only alpha lies inside the unit circle, mod z is equal to 1. So beta is outside. So residue at z is equal to alpha would be, because I have a simple pole, alpha and beta they are distinct, z minus alpha into fz. Okay, this can be found out, limit z tends to alpha, z minus alpha upon 1 minus z minus alpha into z minus beta. So alpha, z minus alpha get cancelled. So this is the residue at alpha z is equal to alpha. Now by residue theorem, now I also know what is alpha minus beta. Alpha minus beta, if you would see, what is the value of alpha? It is minus 3, correct, plus root 5 by 2. So it is minus 3 plus root 5 by 2 and minus minus plus, so 3 plus of root 2 and I do have an I. So this and this get cancelled. So it is root 5 I. So by residue theorem, the z square plus 3iz minus 1 dz is equal to nothing but 2 pi I into sum of residues. And I have only one pole because beta is lying outside. There is 2 pi I upon root 5 I get cancelled. So answer is 2 pi upon root 5. Answer is 2 pi upon root 5. Now this is something which we actually told you at the start of the question. We told you the answer is 2 pi upon root 5 by using this. One can do this question by also transforming into an integration where we can write sine theta and cos theta in terms of tan theta and cos theta. So that is a part of the calculus that you can definitely write. So how do you write it? So you know this is sine 2 theta by 2 cos theta by 2. If you forget, this is upon 1. Now this 1 can be written as cos squared theta plus sine squared theta by 2, correct? So all these things can be used. Now if I divide by cos squared theta, so this is 2 tan theta upon 1 plus tan squared theta. So these substitutions we basically use in calculus when we are doing definite or indefinite integral. And what about this? This is your cos squared theta by 2 minus sine squared theta by 2. For those who do not remember formula, if you remember the approach or the derivation, one can be written as this. So if I again differentiate divide by cos squared theta by 2, this is 1 minus tan square theta by 2 upon 1 plus tan squared theta by 2. So this will give you something which is very tangible, helpful. It will help you in calculus. It will help you solve differential equation, so on and so forth. So if you like our content, please do like and subscribe. Not only it will bolster our confidence, but it will also keep us pepped up so that we can have a useful conversation and utility can be felt by you. So please do like and subscribe. and we want to reach out to the needy and those who are really raring to go and get selected in the examination. So you can visit our website for the forthcoming courses, aryabhatashram.com. You can also come to our offline center, which is 47 Old Rajendra Nagar near Batra Medical, New Delhi, or you can also connect to us in the link given below and the numbers given below. Thank you.